Okay, the third scenario is when you have, number 3, f of x equals x divided by x squared plus 3x. And I'm just coming up with these examples, okay? So, I want to know what's the behavior at x is equals to 0. Okay? So, first of all, you need to get a graph, and you get the graph to graph it.
We can do alpha y equals right?
That is right. So what I'm going to do is I'm going to rewrite it in a way where I can do it by hand. You can do it with the calculator. Go ahead and do it with the calculator. Okay, so I'm going to do it by hand. The x plus 3 is going to be an asymptote at -3. So on your graph, you're going to see that you have that asymptote. And at x is equal to 0, something is happening there. Okay, so as you graph it, then your graph is going to be on which quadrant are you going to have that?
Miss, how do you graph that?
Okay, you go to the second y equals, and then you put the equation x, and then at the bottom you put x squared plus 3x, and then just press zoom 6 to get the standard window. So here I already have my asymptote at -3, and then the graph, it's on the part of the second and first quadrant, and then over here in the third quadrant. Okay, so let me graph that on my picture. So it goes like that. Okay, and then it goes like this. Okay, so that is A3, -3. Okay, now I need to go through my test. Okay, part A, part B, and the C.
Yes. What's that line in the middle when dividing those two lines?
That is an asymptote, because remember in the last assignment you let the denominator equal to 0 for the vertical asymptotes. So vertical asymptote, x cannot be equal to 0 based on this. I don't know if it's an asymptote, but x cannot be equal to 0. And the second one, x plus 3, not equal to 0, and then you find the value of x, so x cannot be -3. So for sure, what's in parentheses, those factors are going to be asymptotes. So at -3, I draw a line going down. That's the asymptote. Okay? Now, part A on testing is f of 0. So at every x, I'm going to put a 0. 0 squared plus 3 times 0. And what is 0 divided by 0? Undefined.
Is that a 2?
What is a 2? Square?
Yeah.
Yes, I'm just following the 2 up here. Yes. So that's undefined. What do you mean undefined? If I see that it's going through something here at 0. So let's see what happens. Part B. Well, look at the graph and study the function. Find out what is the y as you move towards that value, 0, from the right, and then also study the function as you move towards the x equals 0 from the left, and find out what's going on. Well, if I do that, it seems like from the right, I'm approaching a value here, right? So I need to know what value that is. And if I'm coming from the left, I'm approaching a certain value. How can you do that? Well, what you can do is go ahead and go to the calculator. Instead of developing the table that they have on the textbook, if you're following the textbook, I don't know if you've done those types, but okay. Go to second table set, and then change the auto, change it to ask. Okay, change that second table set, and you're gonna go to ask, the independent, yes. Okay, and once you do that, what we're gonna do is we're gonna go to the table, second graph, to go to the table, and I'm gonna put values of x that are close to 0. Okay, let's do the ones from the right first. Give me a number close to 0 that is on the right. Smaller, very close to 0. Point what? 0.5, closer to that. 0.1, even closer. 0.01, closer. 0.001, much closer. So what is that getting close to? I put like 1,000 zeros there. So still what? 0.33. Okay, so my value here is going to be 0.33. So 0.33. Well, I don't know about the other one. It should, right? But I don't know. Let's check it. Let's go to the table and let's put from the left. Give me a number to the left. Point what? Negative 0.001. That's pretty close. Okay. So that is, I got 0.334. Did you get that? Get something closer. Negative 0.00000 infinitive 1. Okay. It still gives me 0.33. So is it the same value?
Yes.
Yes, okay. So let's put that on our answer, 0.33. So, part C, make a conclusion. If you have those three things, then what? Well, the conclusion is, if you have y values and both y values are the same from the right and from the left, that means that something happened. It's not really continuous. Why not? Because
it's equal to
of the, that's right, of the infinitive on part A. Part A says, but wait a minute, there's no value at that point. So what happened then? Well, the function is discontinuous, and what type of discontinuity does it have? Removable discontinuity. What do you mean removable? Yes, because if you go up here into the equation, can you delete the x and the x?
Yes.
That's why it's removable, because that has been deleted.
Because you can change
When it's removable, that means that you take it off. Okay? So, and at that point, you're not going to have a value for that. So that's a conclusion. The function FCN has the function has removable discontinuity. At x equals 0. And that's why I went ahead and I rewrite the function with the denominator factored out, so you can see that, you know, it's a better example. When you are able to eliminate top and bottom, more than likely that's going to be removable discontinuity. Okay? Now, fourth scenario. On the fourth example that I'm going to give you is going to be f of x equals, it's going to be, let's put here, 3x divided by x minus 4. For x equals 4. So, first of all, we're going to have to go with the first part, part A, that asks for what is the value of the function at x is equal to 4. So it's 3 parentheses times 4, 4 minus 4. And 3 times 4 is 12, 4 minus 4 is 0. So this is undefined. Then the part B is when we have to find the behavior. So the limit of the function, what's going on with the function, at x equals to 4 from the right, and the limit of the function at x equals to 4 from the left. If you graph that function, you're going to have it would be like this. You're going to have an asymptote at 4, and that's because the denominator, you let it equal to 0, you find the x, and that's 4. And when x is equal to 0, you can substitute values. So when you substitute values, you're going to see that the graph goes like this. Okay, so as I read the graph, and I read it from the right, because the first limit is when you read it from the right. So as I read it from the right, I can see that the graph is going to, as I approach the 4, to positive infinitive. And then when I read the graph from the left, and as I approach the 4, that graph is going to negative infinitive. So when you have this scenario in which you compare the limits with the value, and if you see here, you have that the value, it doesn't exist, is undefined, and the limits tend to approach the positive infinitive if you read it from the right, negative infinitive so you read it from the left. And if this is the case, if this is the scenario, then the conclusion would be, therefore, the function is undefined at x equals 4. So this was the first part of section 1.3.